To get started, good afternoon, everybody. My name's Tim Shaw, and my partner Ken and I started Brightwave to fight what we thought was a challenge for an entire industry. So we have developed and patented advanced photobioreactors for growing algae. And they're about 300 times more effective than the prevailing technology, and they cost less. So we're going to change. We're basically disrupted to the way algae is grown today and the way that algae biomass is used across a large number of industries. Slide. So algae is unique. It is a versatile, optimal, renewable feedstock for a lot of industries. It's used for everything from, fighting food shortages to developing biofuels and bioplastics. The problem is that the industry today is completely broken. It's worth about $15 billion, and that's in spite of itself because of the demand for algae and biomass. But the industry, it does not optimize yields. It does not control for contamination. And the big sticking point is got unsustainable land requirements. Slide. So what we did at Brightwave is we developed an algae cultivation platform that addresses each of those challenges. We provide consistent high volumes, we provide lab quality biomass, and we do it at a lower price than anybody else out there. Next slide. So the specifics. So again, we've developed this photobioreactor. A couple of the key features. One is that it's internally illuminated. So Ken and I invented an in-water grow light that goes down into the culture inside of this bioreactor. So before Brightwave, if you wanted to cultivate algae or grow algae in a bioreactor indoors, you had to light these things externally. You had lights on the outside of the tanks, and that light had to try to fight through the material of the tank and then fight through the density of an algae culture. So it limited the size of these tanks to no more than maybe 18 inches across. Because we can put lights inside of them, multiple lights, we can expand these things vertically, horizontally, to whatever size the customer needs. The second feature is that those in-water grow lights are self-cleaning. So typically, if you were growing algae or any water-based crop, you're going to have biofouling on surfaces between the plant, the organism, and the light source. So if you're lighting these tanks from the outside, you get algae that biofouls the tank surface. We do away with that. So what we do is inside one of our bioreactors, every liter of culture is getting the same amount of light, and every liter of culture is getting the same amount of light, whether you're day 1 or day 30 into a growing session. And that's something nobody else can do. The internal illumination also helps us maximize footprint efficiency. So one of the key metrics for growing in agriculture, whether you're talking about water-based crops or terrestrial crops, is aerial productivity. So the number that everybody chases on either side of that fence is 25 grams per square meter per day. We're at about 144 grams per square meter per day, about 6 times that standard. So what does that mean in terms of comparison? If you want to compare what we're doing to a typical algae grower, one of our large bioreactors, it's about 12 feet in diameter. It's the size of a bedroom. Will produce as much biomass as a 1-acre algae pond. Compare that to what terrestrial crops are doing. That same bioreactor, about the size of a bedroom, will produce as much protein as 2 acres of soybeans. Next. So one of our initial customers is Minus Materials. They are a carbon negative cement manufacturer. And, one of the key components of Portland cement is limestone. It's mined and then it's burned at high temperatures. Both of those activities generate a lot of CO2. Minus Materials developed an extraction process for algae where they create biogenic limestone from algae. So that process reduces CO2 emissions from cement production by about 60%. Before we got involved with them, these guys were planning to grow all their algae in regenerative quarries outdoors. It was going to take up a massive amount of land, and it was going to be located in remote locations. We provided them with one of our bioreactors, and within 2 weeks, in fact, they were out of the Indy Bio Accelerator in San Francisco. We became the linchpin of their technology. And that's because our bioreactors can provide high volumes. They practically reduce the risk of contamination to 0. And the key thing is that footprint efficiency. So instead of having to grow algae out in the middle of nowhere and truck it to sites, they can co-locate it with manufacturing. And in fact, they're getting ready to do a pilot project with Cemex out in California, or Colorado rather, and they're going to use one of our bioreactors right on the Cemex site. And this is just the tip of the iceberg. Next slide. So we have a very large market that we're going to dip into. That $110 million represents where we think we're going to be in about 6 years. And that is based on converting, that number of customers you see right there from those industries. It's not a far stretch from where we are right now. Next slide. So how are we going to get there? So we take the industries that we want to penetrate, and we separated them into 2 segments. The first segments are the growers. Now, these are those industries, so it's food and beverage, animal nutrition, and aquaculture. They're already using algae. They already know how to use photobioreactors. Our PBRs are turnkey sale for this market. Well, on the other side of the fence, we have feedstock consumers. Most of these prospects and customers are decarbonizing. And then you have industries like pharmaceuticals that are there to take advantage of a lot of the bioactive compounds present in algae. So it truly is a versatile feedstock with a toehold in each of these industries. The cool thing is, as much as we've sought to focus on those first 3 target markets, we are getting hit with opportunities from a lot of the other industries, and we think that reflects a lot of latent demand out there, and we'll come back to that. Slide. So we do foresee a pretty fast revenue growth over the next 5 or 6 years. We're going to sell larger tanks as we get into this. We're going to sell larger systems of tanks as we get into this, and we're going to see our service revenues increase, both because we're doing the installation and maintenance work for a lot of these folks, and then we're already getting asked by a lot of prospects, not just to sell them tanks, but to take on the work of growing the algae for them. Next slide. Competitively, our primary competitor on the photobioreactor side is industrial plankton. There are a lot of companies out there that produce bioreactors, but the vast majority of them are pilot and bench scale. They're very small. Industrial plankton's largest PBR, or photobioreactor, is 1,250 liters, which is going to wind up being one of our smaller ones. So that 1,250 liter PBR, theirs takes up 55 square feet of floor space. Ours takes up 9. Theirs weighs about 4 times as much as ours. And the price of theirs, that 1,250, is about $81,000 compared to ours, which is about $25,000. So we've got a lot of room to grow there. Oh, next slide. The team is Ken Peretti and myself. We started Brightwave 3 years ago. We've been doing this full time since. Ken and I have been working together on algae products and with startups for about the last 8 years. One of our key advisors is Mark Allen, who is really kind of the father of commercializing algae and algae biomass. And then we're getting ready to bring on a really good marketing person in the next couple of weeks. Slide. We do believe that we're a lower risk investment. We are bringing a disruptive technology to the market. It is first in the market, first in the world. We have secured a U.S. utility patent for it. We secured that last year, and we have filed for patent protection in some key international markets. You see those there. We do have a strong management team. I think where Ken and I really shine is we know what we don't know. So we have formed some really solid partnerships and relationships, especially like on the science side of the house. And then we feel like we've got increasing momentum in the market as well. Next slide. So we have 3 customers currently in hand, and over the next 6 months, they're going to produce probably around $200,000 for us. But I wanted to just highlight the traction we're seeing in some of the markets outside those core markets we've targeted. So cement, I mentioned, we're in discussions with 5 different biocement. They're actually not biocement companies. They're cement companies that are implementing biosolutions. Maryland, for example, is going to require companies in 2 years to have organic components to its cement. So we're getting ahead of a lot of those regulations, and we're actually going to do a pilot with one of the international companies here before the end of the year. Sustainable aviation fuel. We started working with a sustainable aviation fuel producer about 2 months ago. They had developed their platform back in 2007 around algae as a feedstock. But about 10 years ago, algae could not meet the demands that they had, and they turned away towards other feedstocks. We're giving them a reason to come back to it, and we're going to do a pilot with them. And then finally, we are doing some work with the Maryland Environmental Service. They run about 170 wastewater treatment plants in the region. We are actually going to take over one of the ones that is non-compliant. We're going to plug one of our bioreactors in as a tertiary treatment. We're going to take clarified water, just run that water through the bioreactor, remove the excess nitrogen, and then release the water. So they're going to have clean water out of it, and they'll have the nitrogen credits that they can trade as well. And that is, oh, I'm sorry, one more slide. We're opening up a $600,000 seed round, and that money is going to go primarily towards standing up our marketing and sales resources and tools, because we really want to expand in that area. But the key requirement for us is to wrap up our fit and finish on the design of the tank. While it does everything we say it does from a performance standpoint, we still think it looks like a prototype, and we have a relationship in principle with Harbor Designs in Baltimore just to do the fit and finish, and then we get this thing over to contract manufacturers. So that's us in a nutshell. Thank you.